adjusting properties absorber to achieve more efficiency in solar cells materials, also show what difficulties is necessary to over to obtain a better quality and better efficiency of solar materials, because it is a two-way. One way is like my colleague, which I meet in India, in Vellore. It was a distinguished professor from Kyoto University, which have a transparent on his laboratory towards 50. And he working very hardly, but you know what is it doesn't mind. When he spent 15 hours in laboratory, his collaborators should be able before them and not go out before him. It is not a joke, but he has a very good equipment. He utilizing a very sophisticated method. It is a molecular beam epitaxy, and few millimeter square of solid cells is very, very extremely expensive. But it is for science. But it is one way. But the second way in problem of preparing better solar cells is stability, time of life. Because, for example, when you buy cheap shoes and you go 2 times to university and it will be a necessary exchange, it is not good sold money. And also, we not should think development and still improving of so-called silica solar cells, because silica solar cells have a particular field of application, and for example, different kind perovskite organic solar cells also have a special way of possible application. And sometimes commercialization of solution, it is a very long time. When I came to India in 2009, and my first conference, one professor told, when you came next time, in our train will be air conditioned, because we cover a roof, organic solar cells, and will be have a free electricity, and over old buses and trains will be adopt and have a very cheap assistant. Up to now, not working, maybe in laboratories, and it was 16 years. And you see that some idea from scientific laboratories have a problem to over such difficulties with a macro, and nobody will be use a molecular beam epitaxy for a growing commercial solar cell. Maybe for space application, maybe, because it is not from economic point of view. Okay. I think that it is some interesting here, and well understand such schedule of my talk, because we are after first point, and now we can focus on the second. How predict and tune absorber properties. And next, we have some discussion regarding advantages and disadvantages of solar materials. And we talked about a possible utilizing simple solution. It is up or down conversion level to enhancing spectral absorbance of sunlight. It is working, but not good. But many years ago, it was also very hot topics. And it was sometimes I asked authors of article, you have a profit 5%, but absorption is 15%. And when thin film absorbing 15% of radiation, which should go across solar cells and give improving 5, it is results not so good, yes? But now is only few practical application and only few manufacturer of solar cells applied such technology. What is a general idea of working of solar cells? Absorb all sun energy and transform into current. But it is a little bit problem, because you know what is technology or methodology interaction radiation with a body, with a solid state. It is three processes: reflection, yes, absorption, and transmission. And what we should do? Decreasing reflection, decreasing transition, and all should be left, all energy should be collected and changed by solar cells. We know that it is not possible from physical point of view, but we try how to improve such second coefficient. It is absorption. And it is one of methodology is a multijunction solar cell. We have one solar cell here absorbing a part of spectrum and exchanging on electricity, but next utilizing remaining. But it is difficult. As I told, people which inform about 40 or more efficiency of solar cells, it is only special production. It is only for application in laboratories. And when I have a lecture regarding tutorial how improving materials properties, I would like explain you such methodology, because it is also interesting but very expensive. You will know processes which it will be good Methodology is very simple. Photons creating electron and hole, and this is collected in a system and is resulting producing electricity. It's no complicated, but as we told, we should thinking about a top of solar cells. Top of solar cells have two important functions. First is connected with anti-reflection. It should minimalizing reflection. Second, in your climate, only temperature and water is very hazardous for surface of solar cells. In my climate, when temperature is, for example, -15, it is also a great problem. It is also connected, for example, with expansion, thermal expansion coefficient, because junction, it is connected with different kind of materials with a different coefficient of expansion. It is a problem because some materials not working properly in low temperature, and sometimes it's snow, and sometimes it's another dangerous phenomena, and it is a mechanical vibration. It's many problems which should be focused on top layer. And next, when you put a black body outside, temperature may be more than 60. Yes? It is not possible. I tried to visit one temple, but it is without shoes, is necessary, but it was not possible because ground temperature was not give opportunity. I think that it is 60 centigrade, it is a minimum. And also temperature excitation. It is also important for solar cells, especially in hot climate. Is necessary to cooling such to achieve good efficiency of such materials, because we also should remember when information about efficiency of solar cells is often connected with it is a small letters, that it is 25 centigrade. But it is maybe in cold winter in India, yes, 25 centigrade. Yes, okay. And next, what we can do? Here is a solar cell radiation. I put here a small formula why we can exchange wavelengths on electron hours, because here is also a problem with sun energy which reach surface of solar cells. You see, it is a yellow, is theoretical, or maybe when we utilizing a plane and we put solar cells on plane which fly in 10 kilometers, and maybe better irradiation. But here we have a problem. It is theoretical because For example, when we have smog and another pollution and some not clean surface, it is also final or intensity of radiation is low. Yes, but as we see here, typical solar cells utilizing only very narrow spectral range. It is very narrow. And from such point of view, we have opportunity to improve spectral absorption because energy of sun is from almost on ground 300 nanometers up to 2.5 micrometers, and it is a great problem because we should adopt our solar cells absorber to absorbing most of such radiation to properly use. Because when we do it, we win, and we improving significantly properties of solar cells. It is a question. We can do tailoring material to our needs. It is possible? Sometimes yes. But it is some advantages and disadvantages. I'll show you how. Because we have, as I told earlier, some possibilities. Here in such graph I take from a review article. It is also open access. You obtain full information. It is easy to pick up. No necessary to obtain a full PDF. It is maybe here. It is a composition engineering. It is a change of composition. I show how is it possible to change properties utilizing such phenomena. Dimensional approaches. We told also when we have opportunity to change size of absorber elements to nano particles, we also have opportunity to tune gap. We also utilizing strain loop stress or stress for such purpose, and it is many methods to absorbing materials. What kind of materials we should use? As we told, we should use chalcogenide or halide materials because band gap, in opposite to oxide materials, is low. Yes, because oxide materials possess a band gap above 4 electronovolts, but it was shown that circa 1.5 it will be most convenient. And we have several opportunities how to do it, but also many materials were investigated up to present very detailedly. And for example, when we need, for example, obtain a particular composition, we can find in the literature what we should make, for example, solid solution to obtain a required band gap. I also show you how we can use quantum chemistry for help us to grow and fast because we not have many attempts such properties. Yes. Yes. Here is many good advantages for halide and chalcogenide materials because they also composition strongly influence, and we can able to predict how on most important electronic properties, like I told, band gap, refractive index, photoconductivity, etc. Here is some examples from my previous work. We investigate photoconductivity, we investigate some dielectric properties, and also we show how is melting temperature. Melting temperature is important for stability of materials. When it is melting is higher, materials is more stronger. And you see not only how changing with a substitution of cationic or anionic part, how we can managing with a simple way band gap. For example, when we make a solid solution, we have opportunity very precisely adjust band gap. But also it's important here when we exchange composition, here's a few opportunities. For example, here, for example, we exchange in anionic part sulfur for selenium, because such materials also recently take attention of scientists, not only pure halide materials, but more stable halide materials. It is important, but also it's important as such parameters. You can see it is a photoconductivity. It is a ratio between conductivity on irradiation, a special formula and special methodology how do it. It is standardized procedure up to so-called dark, because a dark conduction is also photoconductivity is also caused by thermal excitation. And you see what here it is a 5 to 3. It is also one parameter is important is band gap, but a second also is opportunity to generate photocurrent. It is also important parameters. And we investigate many materials. Also, we make some solid solution. And here also, we will use later such information. I show you solid solution of halide materials. It is also single crystal, but most important, and will be also take account later when we will be modified pure perovskite, is such information. You should. It is important because interesting for solar cell application structure exists only when it's a special composition. Because when we have, for example, less than 20% of indium, or we have more than 90, structure of materials is changing. And for solar cells application, only a special kind of structure in solid solution give interesting results. When we go over stability of interesting structure, we not obtain good results. It is also very important because it is connected with a modular interaction difference of ionic radii of both elements. It is and here is a next proposition when we can also make some materials when we change above here we changing cationic part, yes, because excuse me, here we changing cationic part and also see how it influence on band gap. And from previous picture and such, this is one information. But materials is more sensitive for changing band gap or adjusting when we put attention on anionic part. It is from cationic you see. This difference is very small between particular crystals. Here we have also information how we can use halcogenide materials, not halide materials, perovskite, for absorber application, as absorbent application, because, for example, we can utilizing such absorb band for and generate photocurrent in wide spectral range. But sometimes it's a problem with growing particular or big high quality thin films in materials. Here I show you also our interest regarding some solar cells materials, because here we show like we very smoothly able to adjusting a band gap. And I show you how we can utilizing such information. You see, we have a formula. How? Because it was confirmed by experiment, but for example, when we need a band gap 2.8, we need such mutual composition. And such calculation, such measurements were done for many materials. Now, when we have a good access to journals, to library, to method for searching information, we can sometimes utilizing machine learning or artificial intelligence to help us. We can find published results, how properties, how composition should be prepared to obtain a particular band gap. It is chalcogenide and halide materials are very useful materials for such. And also, we can calculate, for example, refractive index. We can calculate another interesting materials properties for also band gap for a different kind. It is first was my papers, and second also is my PhD student calculation. And here also we have opportunity to managing band gap, and it is like absorber. It will be very good because band gap is very narrow. When band gap is very narrow, absorbing range is very wide. Yes, and also it's possible to investigate. But also, I told that not only experiment, not only performing a new junction, but also preparing or doing theoretical investigation, we can improve materials. And here also is information how electronic properties, not only band gap, strongly depend of chemical composition. Here you see how change not only photoconductivity, but also so-called photoconductivity coefficient is changed, because not only important is a maximum for photoconductivity, but also is efficiency to generate photocoolant by materials. And we also, like previously, preparing a solid solution, we can also adjusting electronic properties to our yields. Here we have information regarding different atoms to investigate or existing some solar cells. It is organic hybrid because perovskite utilizing in solar cells is with a cation which is mostly organic element, and I show in next slides. And also we can see that one of most important problem which arise in preparation solar cells is thin film deposition. It is a crucial because we have a different kind of material. We have possible diffusion. When, for example, when some electrode diffuse into absorber, it is strongly change properties of materials. Therefore, a method of preparing thin films, I think, as I remember in one slide, I show some advantages or disadvantages of particular method is important. Because, for example, one of method of utilizing nanotechnology for preparing thin films is make, for example, absorber not from bulk material film, but ultra thin films, utilizing a so-called nano effect. And single crystalline, it is, you know, it is utilizing mild physica, silica. Silica waffle is produced in big sizes, crystals, and is necessary cut for thin plates, but such solar cells possess very good durability, stability, and maybe after 20-25 years should possess not less than 90% of efficiency. It is also important because when people try to apply it, it is most important parameters. But I don't know it is true because when I was in your age, no, I think 2 times older, was a CD plate, and for recording information, and now it's very difficult to find a device, but the people told warranty for keeping information is more than 50 years. But now it's difficult to find device to read such information. It is a joke, but it is also important. And such silica waffle grow as single crystals utilizing a Czochralski method. It was a Polish citizen which his life was not very good, but he was a person which earned huge money, patented very much solution. And for example, he some metal solution with small friction. It was used in railways transport, and he obtained a huge money. But his the best discovery was a method of crystal grow is well known as Czochralski method, and it is method is applied in industry for growing single crystal solar cells. And as I told, organic, people thinking about organic, but it is difficult to apply it. And now is such group, such hybrid solar cells is a most promising material for future, but with combination with a traditional silica junction. I show how. Here, I show some information regarding perovskite. Why perovskite materials? Why? Because it's very popular? No, because perovskite have some good perspectives. When we over some troubles, and for example, especially in Europe, we able to remove very bad lead. When I was a children, we have some figures from lead as for play children. Yes, it is some soldiers, some horses, and we play. But now is a very dangerous element. Yes, because as you remember, I show many crystals which we grow and investigate, which contain hazardous materials like, for example, mercury, like thallium, etc., cadmium. But it's a problem how stable is material. When material is stable and not remove elements to atmosphere, to environment, it is okay. Because lead possess very exceptional properties like hyperpolarizity and polarizing properties. They give them some advantages to be element of solar cells. And at one of slide I show what will be when we exchange such materials. And next topics, what is interesting, people try to utilizing such perovskite for industry. It is from industrial scale. It is also very important because when we not able to grow so-called photovoltaic farms, maybe when in your country, for example, is a many place. It is people not live because it's difficult to live, for example, without water, and it is possible to put some farm, yes, photovoltaic. But when, for example, in Taiwan and countries when Korea, when the countries is very small, but human density is very high, it is a problem. And such solution may be attractive. But it is not question how long. Here is a problem. It is a problem in red. We can remove. For example, we can exchange lead by tin. But efficiency, it is almost 2 times worse. And we should choose a balance. Less toxicity or less efficiency. Unfortunately, in Europe we joking that it is choose not belong to us, but to European Parliament. Yes, they have some regulation regarding cucumber size. Yes, it is not joking. Yes, okay. And here, you remember a slide when I show solid solution of some halide materials. When I told that it is a particular concentration of mutual concentration between bromium and indium caused structural changes. And here also is important because you know from physics when some materials possess so-called indirect and direct gap. For photovoltaic, direct gap materials are more convenient and more useful and more efficient for application in solar cells. It is one advantage. As such, information we can obtain from simple measurements, or when we thinking about material, we can perform quantum chemistry calculation, and we should where is bottom of conducting band and top of valence band, and when is one on another, it is okay. When it's not, we should choose. But we have composite with 3 elements, and we A, B, X, 3. It is a chemical formula of perovskite, and we can chemically change A, B, or X. And in next slides, I show you what is the effect of such substitution. But also we can back to some restriction about. Yes, because when we have idea to grow a new materials with a new composition, we should, utilizing very short formula, check if final structure for first exists, and for second, which structure, crystal structure appear, because for photovoltaics, only from 0.8 up to 1 is convenient for perovskite structure and for possible application as a solar cells absorber. And here I show you some information regarding efficiency, some important properties of solar cell when we adduce cationic part. Cationic A, we substitute formalidium lead iodine. It is a crushed material, but such formalinium we substitute by cesium. And when we utilizing 15% of cesium, we obtain a high-just efficiency. It is a 16.1%. I also include a link to such free open access article. It is a review article when you have opportunity to find such information. I try to not utilizing huge number of papers to give you more convenient find information which was presented. And you remember, here is the best 16.1%. And second, when we utilizing as preliminary material methylammonium lead iodine, we also obtain some information, but here small amount of cobaltium, yes, when we exchange cobalt for lead, we obtain some interesting increasing. Not so big, but it is necessary to understand why 1 and 6% of cobaltium improving significant, not significantly, but it is 1 or more percent efficiency. I probably think that it is connected with introduced some so-called some changes in electronic structure, and maybe by introducing a defect. Some defect give us opportunity to also improve properties of materials. And also another opportunity to exchange some cationic part B side when we exchange some ion of lead by stbium. It is interesting because it is non-valent material, and also we can see what is efficiency. Efficiency is not so good in compared to previous, but composition is more complicated. Next, we have some, it is small letters, I'm sorry, but efficiency of such metallo-organic absorber also is not so good. Here is some of iodine we substitute by bromium, and efficiency decreasing. And why I show you? Because it is important to show you that not all our attempts give a positive result. Sometimes negative results may be also interesting, but from fundamental point of view, but from practical point of view, no. But such materials which possess organic part is difficult to calculate, and it's necessary to perform a much of experimental work. And here also are depicted some electronic properties, because a band gap is one element, but also it's interesting to see how introduced changes in chemical composition influence of absorbance and performance of solar cell junction. It is also interesting because it is significant significant change do a small change of composition. Here also is interesting situation, but we have a double changing, because we have a change of a cationic part and anionic. Yes, here is the same cation, but composition of anion, especially iodine, is and bromium is changing. It is also influence of absorption, because absorption range changing, but fortunately not strongly influence on best performance. And next, is tune properties by utilizing pressure. Unfortunately, my lecture, which explain possibilities how keep effects like hydrostatic pressure utilizing chemical interaction will be tomorrow. But I try to show how we can do. It is a similar equipment like we discussed yesterday, and it was perform measurements of structure of materials. As you remember, not only optical properties may be monitoring utilizing anvil cells, but also we can perform structure measurements utilizing XRD radiation. And also you can see how electrical resistance changing under pressure. It is one of method of changing or adjusting properties of material for solar cells utilizing pressure. And here is also opportunity to bandgap tuning utilizing nanotechnology. When we put, for example, ultra-thin film, even solid absorber, we also have some advantages how improving properties. But here, only interesting in compared to previous investigation is tiered results when it is a small amount of bromium, when total efficiency of such perovskite solar cells was below 15. And here is a summary of possibilities of tuning bandgap when we able to move bandgap, taking account different technology, but here is mostly focused on adjusting chemical composition. It is most easy to apply to such method because not need complicated equipment. Here is some solution. It is here is it is a cross section of heterostructure. It is now we have opportunity to perform such measurements and do to some technologies, and is sometimes too easy how structure of and microstructure of particular layers also can influence on efficiency of solar cells. It is a technical information, but also next nanoparticles in solar cells. When we accept solid absorber, we can use nanoparticles. Here is not perovskite, it is a silica particles. We can also improve properties, absorbance, and efficiency of materials. Here is many attempts how do it because it is a different geometry, has a different size of nanoparticles, different shape of nanoparticles. I also give a link to such articles when such attempt to improving materials, absorbing materials properties is also interesting. They also utilizing some nanoparticles to cover the surface of solar cells to decreasing significantly reflection coefficient. It is also important for absorbing sun energy. And in the last topic, I'm sorry, last topic is connected with up conversion and dump conversion for application to solar cells. As I told, we should utilizing lost spectrum of sun energy, especially utilizing such high energy spectrum and long but less energetically strong energy from red and infrared spectral range. Here we can use down conversion when UV photon we exchange on, for example, circa red, and also down conversion when we able to reach spectral range up to 1 micrometer, 600 nanometers, to back in a region which is absorbed by silica. And here is also interesting file, a picture which shows how much energy we can obtain when we have ideal up and down conversion. It is from a theoretical point of view is quite big because it is such red and yellow. But it is theoretical. From practical point of view, is not so good. But also is I found a very nice solution because I like a nice solution in physics, in mathematics. It is very good when, for example, upconversion level is here because it is light radiation go across, and such remaining is a pass for junction is transformed by upconversion level. Here is a typical reflection media. But also is interesting that when he have a porous structure, it is give better results when is flat surface interface between upconversion layer and absorbing media. It is interesting because we, for example, not discuss during what is it? Analyzing efficiency of solar cells, how much energy is diffused or broadcasting by some internal reflection, because you know that in interface between two materials with a different refraction index, we always have an opportunity to reflect. It is also good when engineers which constructing such system remember about also elements which may be decreasing situation. And only a few slides and will be and multi-junction cells. Maybe I'm sorry. I back only one because it will be good. And for example, when we have here not utilized but such junction radiation, we can put here next, which will be focused to absorbing radiation which is not absorbing by such element. And we can do, for example, three. One for UV, silica, and third for infrared spectral range. But it is difficult to do some technical problems, because idea is very good, but some reflection, absorption, do some, for example, electrodes, etc., maybe also decreasing results. But such and idea is very very simple. We have one junction, they absorbing some radiation, and for example here is maybe red, maybe, and it is mid-red radiation is absorbing by second, and we have utilized more energy for converting into electricity. Here is also example of some junction, two junction solar cells, and it was interested that they have opportunity to absorbing radiation in spectral range above 1 micrometers. And in right side you see also tandem. It is multifunction solar cells which is connected from perovskite and carbon, silica solar cells. It is also interesting. In my presentation also you find some information of different application of effects of perovskite connected with interaction with radiation, and also some information regarding applicability of particular method on thin film growth, because sometimes it's necessary to utilizing different method to grow particular layers. It is a very difficult problem, and it is increasing expenses for preparing solar cells, and is called back time, back for money is very long. And here also we have some detailed and fresh, because yesterday I pick up actualized information regarding challenge in best cell production. It is in laboratories up to 40%, but I think that in practice below 30 is now is application. And here is also information regarding a kind of solar cells and how during last 7 years has been proven efficiency. And last slide is also how perovskite materials of generating electricity. And when remember that the have efficiency percent, now at 20, but the money was perfectly, but wait for in cover roof by organic cells and free energy for cooling. It was last slide for such session. Thank you, and I'm sorry for elongation. Thank you for your attention.